Okay, so if I give you a point in the xy plane, the first thing we're going to do is plot it and see what it looks like. So if I plot the point -3, -5, I'm going to go over -3. I'm going to go down -5. And we're drawing an angle here. The terminal side of this angle is the hypotenuse. I didn't do a very good job there. Okay, so for the angle theta, we'd actually be starting at 0 and going all the way around to the terminal side. I'm drawing the terminal side to go through the point -3, -5 that I was given. But what we're going to do to find the trig functions is we're going to assume that theta is just that angle, the acute angle that's within the triangle I drew. Okay, so let's look at what we're doing here. The triangle I have is a right triangle. There's my theta. That side has a length of 3. That side has a length of 5. If I want to find all 6 trig functions, we need to know the hypotenuse as well. So we get C for the hypotenuse equals the square root of a squared plus b squared. That would be 9 plus 25, right? 3 squared plus 5 squared equals the square root of 34. And I checked to see if I can simplify that. Well, 34 is 2 times 17. Those are both prime numbers. I can't do anything. So my hypotenuse, we're just going to say, is the square root of 34. So based on the triangle yes? Okay, so let's start with the 3 trig functions that we know really well. Sine, cosine, and tangent. So sine theta, cosine theta, and tangent theta, we're going to find them first, then we'll find their reciprocal functions. Sine theta is opposite over hypotenuse, right? We're using SOHCAHTOA. Opposite of my theta is 5. My hypotenuse is the square root of 34, and actually leave some room in front of the numbers you're writing because we're going to have to determine if it's positive or negative, so I need a little room for a negative sign in case I have to put it there. Now, we got to decide if it's positive or negative. Well, we are in quadrant 3. My all-star trig class tells me tangent is the only thing positive in quadrant 3, right? So sine is going to be negative, so we're going to put a negative in front of this number. Then we need to rationalize it. So to rationalize it, we're going to multiply by square root of 34 over square root of 34, right? And I'm going to get negative 5 times the square root of 34 over 34. Cosine theta is going to be adjacent over hypotenuse. Our adjacent side is 3 over hypotenuse of the square root of 34. We need to determine the sign of it, the SIGN. In quadrant 3, tangent's the only thing positive, so we're going to be negative for cosine here. And then we rationalize it. So I'm going to get negative 3 times the square root of 34 over 34. Tangent is opposite over adjacent, so we're going to get 5/3. And we have already looked, in quadrant 3, tangent is positive, so it's just 5/3. Now we got to do our reciprocal functions. Let me make some room here. Okay, sine goes with cosecant theta, cosine goes with secant theta, and cotangent is the reciprocal function of tangent. When I do these, we don't want to look at our final answers after we've rationalized something, because then I would flip it or take the reciprocal and have to rationalize again. So I want to look at this ratio for sine, take the reciprocal, that gives me the answer for cosecant. So it's going to be negative square root of 34 over 5. For cosine, I want to look at this ratio. I get negative square root of 34 over 3. And for cotangent, we get 3 over 5. Let's try another one. My point is negative 12, 5. So I'm going to go negative 12 in the x direction. So let's make that 12. And it's really negative. And then we're going to go up 5. That will be the terminal side of my angle. So theta is really that entire angle. But the theta we're going to work off of is the one that comes off of the origin. So the right triangle we're using here has a side length of 12 and 5. There's my theta. We need to find the hypotenuse. So to find the hypotenuse, we're going to say C equals the square root of a squared plus b squared. 5 squared is 25. 12 squared is 144. That gives me the square root of 169, which is a perfect square. It's 13. Okay, so on my triangle here, I have all positive sides drawn, and then we're going to use our trick to assign the positive or negatives. So we're in quadrant 2. Sine's going to be the only thing positive. All right, so we need sine theta, cosine theta, tangent theta, and their reciprocal functions. Cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. Okay, so sine theta, I'm looking at this triangle down here. Opposite over hypotenuse would be 5 over 13. In quadrant 2, should sine be positive or negative? It's positive. So then cosecant is just the reciprocal. It's 13 over 5. There's no rationalizing in this triangle, which is nice. Cosine is adjacent over hypotenuse, so we're going to get 12 over 13. In quadrant 2, is cosine positive or negative? Negative. So put the negative there, and then for secant, we find the reciprocal. Tangent is opposite over adjacent. We get 5 over 12. Should it be positive or negative? Negative, because sine is the only thing positive in quadrant 2, and cotangent is the reciprocal. Okay, we're going to try the point 5, negative 5. So I'm going to plot that. I'm going to go over positive 5, down negative 5, draw the terminal side of my angle, and my angle really is going almost all the way around the circle. But the angle we're going to work off of is let that be theta. So my triangle is actually isosceles. It's a 45, 45, 90. And we worked with those special cases last time. So there's my theta, that side length's 5, that side length's 5. We have to find the hypotenuse. Which is the square root of 5 squared plus 5 squared, right? Well, 25 plus 25 is 2 times 25, right? And if I do 2 times 25, I see 25 is a perfect square, so this can be simplified to be 5 root 2. Okay, or I could have gone, okay, it's the square root of 50, and then I would have gone backwards and gone, well, 50 is 2 times 25. I can pull the 5 out from the 25. So my hypotenuse is 5 root 2. All right, and then we've got our all-star trig class that tells us since we're in quadrant 4, cosine's going to be the only thing that's negative. So our 6 trig functions: sine theta, cosine theta, tangent theta, cosecant goes with sine, secant with cosine, and cotangent with tangent. All right, so sine, opposite over hypotenuse. So I get 5 over 5 root 2. Quadrant 4, cosine's the only thing that's positive, so sine is going to be negative. Now this will simplify. 5 divided by 5 is going to go away. So I've really got negative 1 over square root of 2, right? Which we know, if I rationalize that, is going to be negative root 2 over 2. 45 degrees is pi over 4. These are angles off of our unit circle, correct? And I know it's 45 degrees because the side lengths are the same, 5 and 5, so it's isosceles, has to be. That's why I know the angle. The other examples, I had no idea what the angles were because the side lengths didn't mean anything to me. All right, cosecant then, we want to take the reciprocal of that. It's just going to be negative root 2. Cosine is going to be the same as sine because adjacent and opposite are the same length. Right? They're both 5s. So when I simplify it for cosine, I'm going to get the same answer I did for sine, except what's different? It's going to be positive because we are in quadrant 4 where cosine's the only thing that's positive. So then secant will be a positive root 2. Tangent, opposite over adjacent. Well, that's 5 over 5. So we're going to get 1, and it's going to be negative because we're in quadrant 4. Well, the reciprocal of negative 1 is also negative 1. All right. We're going to make it a little bit more complicated. And the first thing we got to be able to figure out for the ones that I'm going to make a little bit more complicated in the next example is, given certain information, how do I determine what quadrant I'm in? Well, what we're going to use is our all-star trig class trick. And then figure out, based on a process of elimination from the given information, what quadrant must I be in? If tangent is less than 0, that means tangent's negative. I got to be either in quadrant 2 or 4. Cosine is greater than 0, that means cosine is positive. So which quadrant am I in? I got to be in quadrant 4, right? Okay, part B, sine is less than 0, so sine is negative. Where is sine negative? Quadrant 3 and 4, where only tangent and cosine are positive. Our second piece of information is cosine is less than 0, so cosine's negative. What quadrant must I be in? I'm in 3. All right, let's do another one. Sine is less than 0, so sine is negative. I'm either in 3 or 4 again. And cosine is greater than 0, so cosine's positive. Which quadrant am I in? I'm in quadrant 4. All right, for part D, they gave it to me in terms of cotangent and secant. But my all-star trig class only tells me about sine, cosine, and tangent, right? So if cotangent is greater than 0, that means tangent, its reciprocal function, is greater than 0. And if secant is less than 0, that means that cosine, which is secant's reciprocal function, is less than 0. So based on that information, I can decide where I am. Okay, and I rewrite it because if I just go, oh, secant theta is less than 0, then I got to really think for a minute. What does that mean? Where do I put that in the 4 quadrants? So I just turn it into cosine. All right, tangent is greater than 0. So we got tangent's positive. That means we are in quadrant 1 or 3. Cosine is less than 0. So which quadrant are we in? We are in 3, where tangent is the only positive trig function. Well, tangent and cotangent. Okay, I want to find cosine theta and cosecant theta if tangent is negative 2/3 and cosine is greater than 0. Okay, well, the first thing I got to figure out is what quadrant am I in? Tangent's negative, so I am either in quadrant 2 or 4, and cosine is greater than 0, cosine's positive, so I am in quadrant 4. All right, so now I'm just going to draw a right triangle. That's my right angle. I'm going to pick that to be theta. Tangent is opposite over adjacent. I'm going to ignore the negative because we're going to assign the positive and negatives based on the quadrant we're in. And I'm just going to look at the 2/3 and I'm going to say, okay, well, this is going to be my opposite and this is going to be my adjacent then. It might not be. It could be that my opposite's 4 and my adjacent's 6. I don't know. That's a simplified fraction. But it's going to help me figure out the ratios doing it this way. So I'm going to say that the opposite is 2, the adjacent is 3, and I'm going to use the Pythagorean theorem to find the hypotenuse. So 2 squared is 4, 3 squared is 9. We get the square root of 13. All right, so that's my hypotenuse. Now we're not asked to find all 6 trig functions this time. We're just asked to find cosine and cosecant. Now cosecant goes with what? Goes with sine. So I'm going to make my life easier and I'm going to find sine and then take the reciprocal. All right, cosine is adjacent over hypotenuse. My adjacent is 3. My hypotenuse is the square root of 13. We are in quadrant 4 where cosine is the only thing positive. So it's positive. And we rationalize it. Multiply by square root of 13 over square root of 13, and I get 3 root 13 over 13. For sine, we would get opposite over hypotenuse. That's going to be 2 over the square root of 13. And in quadrant 4, cosine's the only thing positive, so sine's going to be negative. Now, I don't have to rationalize that one because they didn't ask me for sine. I'm only using it to get the reciprocal function. So flip it, and that's our answer to cosecant. Negative root 13 over 2. Let's try another one. I want to find sine and tangent if secant theta is negative 3 and tangent is greater than 0, so it's positive. Well, again, I like to work in terms of sine, cosine, and tangent. So secant is 1 over cosine, or cosine is 1 over secant, so cosine is negative 1/3. Now let's determine which quadrant we're in. Cosine's negative, that's going to happen in quadrants 2 or 3, and tangent is positive, so we are in quadrant 3. My triangle that I'm going to draw, I'm going to pick that to be my theta. Cosine is negative 1/3, so we're going to look at the 1/3. Cosine is adjacent over hypotenuse. So I'm going to make the adjacent side 1, and I'm going to make the hypotenuse 3. Now we got to use the Pythagorean theorem, but we're going to have to rearrange it to get the other side length. So if I call this side length A and this side length B, and we're solving for B, then I've got A squared plus B squared equals C squared, or B equals the square root of C squared minus A squared. Our C is the hypotenuse, it's 3. 3 squared is 9. Our A is 1. So we're going to get the square root of 8. And 8 is 2 times 4. 4 is a perfect square, so we can bring a 2 out, correct? And we're going to get 2 root 2. All right, so my B is 2 root 2. All right, we're asked to find sine and tangent. Sine theta is opposite over hypotenuse. My opposite is 2 root 2 over my hypotenuse is 3. And we are in quadrant 3 where tangent is the only thing that is positive. So sine must be negative. We're asked to find tangent theta. Tangent is opposite over adjacent. So we're going to get 2 root 2 divided by 1, but I don't need the divide by 1, right? And we're in quadrant 3 where tangent's positive, so it's positive 2 root 2. Okay, evaluate if possible the sine and tangent functions at the 4 quadrangles. You've already been doing this off of your unit circle. Okay, if we're at the quadrangles, we've already talked about this, that's where the axes divide the xy plane into its quadrants. So we're going to be looking at 0 or 2 pi, pi over 2, pi, and 3 pi over 2. And we're finding sine and tangent. I need to know the coordinates. Well, the coordinates at 0 are 1, 0. At pi over 2, it's 0, 1. At pi, it's negative 1, 0. 3 pi over 2 is 0, negative 1. All right, so they asked me to find sine of each of these. Sine is our y-coordinate. So at 0, my y-coordinate is 0. At pi over 2, it's 1. At pi, it's 0. And at 3 pi over 2, it's negative 1. All right, we're asked to find tangent. Tangent 0, tangent pi over 2, tangent pi, and tangent 3 pi over 2. Okay, now this is where in the question they said, if possible. What is not possible is when we're undefined, when we divide by 0, and that's going to happen with tangent. Tangent of 0, tangent is sine over cosine. So we get 0 over 1. Well, 0 divided by a number is just 0. At pi over 2, we get 1 divided by 0. That's undefined. At pi, we get 0 divided by negative 1. Well, that's just 0. And at 3 pi over 2, I get negative 1 divided by 0, and that's undefined. Okay, so if I give you a terminal side that gives an angle theta, right? It's in standard position, starts at the x-axis, goes to the terminal side. The reference angle that goes with it, the one that allows me to evaluate the trig functions, is the angle that is the closest from the terminal side to the x-axis. So for this first one, if I want to get as quickly as I can to the x-axis, I'm going to go over here, and we're going to call that theta prime. Right? My other option for getting to the x-axis would be to go here, but that's not the quickest way to the x-axis, so I don't want to do that. All right, in my second sketch here, the quickest way for me to get to the x-axis would be right here. So I would call that my reference angle. And on the last one, the quickest way to get to the x-axis would be right here. So I'll call that my reference angle. Depending on which situation I have, changes how I calculate finding the reference angle. Okay, so let's look at a couple of these and see how we find the reference angle. 345 degrees. Well, if we're in degrees, this is 90, this is 180, that's 270, and this is 0 or 360. So we start at 0. We go to 345 as our terminal side. So 345 is going to be somewhere in between 270 and 360. So my real theta starts at 0 and goes all the way around to there. But my reference angle is going to be right there. So I need to figure out between 360 and 345 how many degrees are left. Well, so we're going to say 360 degrees minus 345 degrees is equal to 15 degrees. That's my reference angle. All right, let's try it for 5 pi over 6. Well, we know to label our pi over 6's, we're going to count around the circle by 6. That's 1 6, 2 6, 3 6. Whoops, I missed 3. 1, 2, 3, 4, 5. So 5 pi over 6 is right there, where my theta starts at 0 and goes to that terminal side. My reference angle, though, is going to be between my terminal side and the x-axis. So this is pi. If I want to figure out my reference angle, it's going to be pi minus 5 pi over 6. Well, pi is the same thing as 6 pi over 6, right? Minus 5 pi over 6 gives me pi over 6. Now, if you go back to when we did our unit circle and we were drawing our rectangles, you would see that 5 pi over 6 lines up with pi over 6. It is the reference angle we've been using from the unit circle. So that one I kind of just know. Okay, this one's supposed to be negative 135. So we're going backwards or clockwise. So I'm going to write my angles as negatives on my quadrangles. Okay, so here we're at 0. Here, this would be negative 90. That would be negative 180. That would be negative 270. And we're at negative 135. So that is somewhere in between negative 90 and negative 180, right? So my reference angle is in between negative 180 and negative 135. Reference angles are always positive. So how many degrees are in between those two things? Well, for me to figure it out, I'm just going to make them positive. So 180 minus 135 gives me a 45-degree reference angle. All right, so use reference angles to find sine of 135 degrees. All right, so we have 90 degrees, 180 degrees, 270 degrees, that's 0 or 360. 135 is in between 90 and 180. So from 0 to our terminal side is 135. From 135 to 180 is our reference angle. So that's going to be 180 minus 135 is equal to 45 degrees. Well, 45 degrees, what is that in radians? We know what that is. Halfway between 0 and 90 would be pi over 4, right? Because 90 is the same thing as pi over 2. So the reference angle is pi over 4. What is sine of pi over 4? It's square root of 2 over 2. Now, We're in quadrant 2. So is sine of 135 going to be positive or negative? It's going to be positive, so sine of 135 degrees is the same thing as sine of 45 degrees, and it's positive because we're in quadrant 2. What if I give you tangent of 14 pi over 3? 14 pi over 3 is not between 0 and 2 pi. So before I can find my reference angle, first we need to find a coterminal angle between 0 and 2 pi. Okay, so that goes back to another lesson. So we want to find an angle that's between 0 and 2 pi. We do that by subtracting 2 pi, right? So what I do in my calculator is I type in 14 over 3 minus 2. We find the answer and we stick a pi back on it. Well, 14 over pi minus 2 gives me 8 over 3. So this is 8 pi over 3. That is still more than 2 pi. So we do it again. 8 pi over 3 minus 2 pi. The calculator, I type in 8 over 3 minus 2, and I get 2/3. So we've got 2 pi over 3. So if I draw that, my pi over 3's are right there, right? So this is going to have a terminal side of 2 pi over 3. There's my actual theta. My reference angle then is in between 2 pi over 3 and pi. Well, we know from the unit circle, 2 pi over 3 goes with what? Goes with pi over 3. So pi minus 2 pi over 3 would give me pi over 3 as a reference angle. We're trying to find tangent. Tangent of pi over 3, we're here where the coordinates are 1/2 square root of 3 over 2. Tangent is sine over cosine, so it's the square root of 3 over 2 divided by 1/2. If I simplify that, flip it and multiply, I'm going to get square root of 3. Okay, but that's tangent of pi over 3. We're in quadrant 2. So we're finding tangent of 14 pi over 3, which is equal to tangent of 2 pi over 3. In quadrant 2, is that going to be positive or negative? It's going to be negative because in quadrant 2, sine is the only thing that's positive. So we get negative square root of 3.